The derivatives of inverse trig functions are algebraic, even though the inverse trig functions themselves are transcendental. So the derivative with respect to x of the arc sine of u is u prime divided by the square root of 1 minus u squared. The derivative with respect to x of arc tangent is u prime divided by 1 plus u squared. And the derivative with respect to x of arc secant is u prime divided by the absolute value of the square root of u squared minus 1. Now, if you know those, you're in really good shape because the derivative with respect to x of arc cosine is minus u prime divided by 1 plus u squared. So the derivative of arc cosine is minus the derivative of arc sine. Just like the derivative of arc cotangent is minus the derivative of tangent, and the derivative of arc cosecant of u is minus the derivative with respect to x of arc secant of u. So let's try to take the derivative with respect to x of the inverse sine of 2x. Now you know the form d dx, turn my board here, of the inverse sine of u is equal to u prime divided by the square root of 1 minus u squared. In this case, u is 2x, so u prime is going to be 2. So this derivative becomes u prime, which is 2, divided by the square root of 1 minus u squared. And you do want to simplify this. So this is 2 divided by the square root of 1 minus 4x squared. Now, if I have the, I'm trying to take the derivative of the inverse tangent of 3x, then I know u is 3x, du is 3, and the derivative with respect to x of the inverse tangent of u is u prime divided by 1 plus u squared. So this becomes 3 divided by 1 plus 3x squared, or 3 divided by 1 plus 9x squared. Now, the way I've been writing it has seemed like maybe an extra step or two, but when you get these weird arguments, it's helpful. Here, let me let u equal x to the 1/2. U prime is 1 over 2 times the square root of x. Or you can write this with a negative exponent. So the derivative with respect to x of inverse sine is u prime divided by, the square root of 1 minus u squared. I should have written that down here, but that's okay. So this is 1 over 2 times the square root of x times 1 over the square root of 1 minus u squared. So this is x to the 1/2 quantity squared. So this becomes 1 divided by 2 square root of x times the square root of 1 minus x. So you can leave it this way or take it in like this. Combine the square root there. So this is x minus x squared. Now let's look at the derivative with respect to x of secant inverse of e to the 2x. I'm going to let u equal e to the 2x. So du is 2e to the 2x. Now I want you to notice that this is always positive. And I know the derivative with respect to x of secant inverse of u is u prime divided by the absolute value of u times the square root of u squared minus 1. Now I'm going to do this down here. What is u squared in this case? This is e to the 2x squared, or you can write this as e to the 4x because you multiply those two numbers. So this derivative becomes u prime, and where was my u prime? So it's 2e to the 2x divided by the absolute value of u, and I can just make that positive because I don't need the absolute values, because e is always positive, the square root of u squared, so e to the 4x minus 1. Now I can simplify this down to 2 divided by the square root of e to the 4x minus 1. Now sometimes you have messy derivatives, and when you have those, you do need to go on and clean it up. So if I were to do this one, y prime, let's see, the derivative of inverse sine is 1 divided by the square root of 1 minus x squared. And now I'm going to use the product rule. So this is x times the derivative of the square root of 1 minus x squared. So it's going to be times 1/2, and then 1 over the square root of 1 minus x squared times 2x, and then plus the second, the square root of 1 minus x squared times the derivative of the first, which is just 1. So let me rewrite this. This is 1 over the square root of 1 minus x squared. Those go away, and I'm left with, what am I left with in the numerator? I'm left with, oh, I needed a minus sign there, didn't I? Yeah, because I had the negative. Minus x squared divided by the square root of 1 minus x squared plus the square root of 1 minus x squared. Now we want to get a common denominator here, and that common denominator is 1 minus x squared. So I'm going to factor it out. So this becomes 1 minus x squared plus 1 minus x squared. So this becomes 2 times 1 minus x squared divided by the square root of 1 minus x squared. Now you see how beautifully this simplifies. 2 times the square root of 1 minus x squared.